Welcome to Study Loop.
Okay, so to solve for the exposure time of the pinhole camera, we need to follow these steps. So first, we'll be calculating the effective f number of the pinhole camera. So let's do that. So to calculate the effective f number of the pinhole camera, we need this equation where f stop is equal to the focal length over d. D is the opening aperture or the diameter of the pinhole. So that's gonna be 70 millimeter divided by 1 millimeter. So that's f over 70. Now, so that's our f stop for the pinhole camera. So we found this. Now we need to set the exposures equal for both of the cameras. So let's do that. First, let me mark that. So that's our first step. Right. So this is step one. Now we're setting the exposures equal for both cameras. So that means exposure 1 should be equal to exposure 2. And we know that exposure is nothing but multiplication of area and time. So that means area of the first camera is equal to the area of the second camera. And to find out the area, since it's a circle, so it's going to be area is equal to pi over 4 times diameter squared. So we can put that number over here. So it's going to be pi over 4 diameter for the first camera is equal to pi over 4 diameter of the second camera times T2. And from there, we can substitute these two diameters from this equation, this following condition where D should be equal to F over F stop. So let's do that. So it's going to be pi by 4 times T1 F squared over F stop squared, which is equal to pi over 4 pi over 4 times T2 F squared over F stop 2 squared. Now we can get rid of few things. For example, pi over 4, this F squared. So then we can find out the relation between T2 and T1. So from here we can write T2 is equal to T1 times F stop 2 over F stop 1. And we can put the numbers now. So it's going to be 1 over 250, 2/50th of a second, then 70 over 11 squared, and that's going to be 0.16 second, or 1/6 of a second. Thank you.